We have two main laboratories for performing the experimental activities in this project. First, we have a facility where we can simulate the conditions of an atmospheric re-entry of a space vehicle to the Earth, and so test the samples, material samples, to understand if they can be used for space applications, for space capsules or space planes. In particular, in the frame of this project, we will perform tests on small samples like this one that will be inserted into a mechanical arm and placed inside a test chamber and exposed to a very hot and supersonic flow that heats it up to very high temperatures, up to 2000 degrees.
The role of Mercidian nipples in CHARME is the design of prototypes and testing conditions, and the carrying out of part of the experimental activities. So the main challenges we are dealing with regards mainly the adaptation of our facilities for these issues. In particular, for example, the propulsion laboratory of our institution was set up primarily for the characterization of the performances of hybrid rockets without a direct concern for the material characterization, since we always used classical material for thermal protections and for nozzle. Now we had to understand which is the best way to characterize the new materials in the extreme combusting environment. So we are designing a first setup to test a small specimen of the new materials, to have a first screening of the best candidates. And then we intend to test this sample placed in the combustion chamber, and then nozzle insert and complete subscale nozzles.
Well, the collaboration with the international partners in this project is very significant, since they not only manufacture these samples for the tests, but they also, after our experimental activities, receive these samples back so that they can perform further analysis of the material behavior, for example, with microscopes and other experimental techniques.